Well, my name is Aitana, and I'm going to present the work I did together with Alejandro Toselli and Enrique Vidal about, well, yeah, the title is really long. Maybe it's like we are basically presenting an improvement we made to it's the website, but also the implementation of the search in a specific data set of ancient manuscripts. So this is the guide I'm going to use. I'm going to introduce a little bit of the motivation of this work and also how is our system working, how did we implement it, some conclusions, and a little short demo of the search, like the search of musical symbols. So this work is based on information retrieval, like music information retrieval. It's also like, obviously the recognition is important, and yeah, we don't focus that much on transcription, but recognition. This means like we don't look for specific transcription of a note or a melody with the dataset, but like spotting the notes and taking more into account the information we are given by the optical model. So yeah, we worked with the Borao 253 manuscript, which is a Germanic Gothic notation manuscript. It's monophonic. This means it doesn't have any polyphony. It doesn't have also any rhythm notations or anything. It just has the lyrics and the music. And we just, in this work, we treated just the lyrics, even though you can, just the music, even though you can, in the searcher, in the demonstrator, you can look for the lyrics, but this work, I'm just going to talk about the music. We take from the starting point the demonstrator that was created through the work done by Jorge Calvo and Alejandro Toselli, Enrique Vidal, and John Andreu Sanchez. And yeah, why we want to improve what we already had, which, okay, obviously, I mean, it's ancient music, but there are a lot of manuscripts with this kind of notation. So I feel it's important not just focusing on the modern notation, but also on this kind of manuscripts, because there are a lot of abbeys or religious buildings with ancient manuscripts in them that are not transcribed yet. So it's a really important work to do. Okay, some work in this field has been done, but maybe they are like more focused on looking for just information retrieval in manuscripts, but that are not fully automatically recognized or transcribed. And also the ones that are fully recognized, automatically transcribed, whatever, they use like this best hypothesis of transcription, and not they don't take into account like the probabilistic spottings that you can use for maybe improve your recognition and your information retrieval system. So it's limited comparing to probabilistic indexing, which is the approach we are using. So in this work, we incorporate musical queries in the demonstrator, because now like the recognition is still done with spotting notes, but I'm going to explain the notation after. It's just single geometrically notes and not musical. Like you cannot ask for a melody like notes like do, re, mi, or whatever. You just need to put like the geometrical location of the notes if you want to look for it. So it's not user-friendly for musicians and musicologists that want to look for some information in this dataset. So it's like we are mixing probabilistic indexing in the recognition and musical information in the search time. So when we want to query a system, we have the clefs. We want to recognize in this dataset, they are like F clef and C clef. I don't know how to say that in English, but it's like F, A, and Do. You have N with the location where the clef is. Here it's F3 because it's an F clef in the third line. And also for the notes, as I said before, it's a geometry. So it's S for space, L for the line. Obviously, you can have additional lines at some point, and you just put like L5, or if it's below the staff, you will put S-1 or L-1. So this struct for the line will be L2 because in the second line, S1 because it's the first space, and so on. So now we, like I said before, the optical model recognized in the spots of the nodes or the clefs. So we have for each node, not each node, but each recognized symbol, we have the symbol also the probability when in which it was recognized, and allocation, like a bounding box in where is a note. But okay, has a problem. As I said before, it's like we are looking for geometry, not music, and this is not musical friendly. Like you are not supposed to look for spots in the geometry. If you want to look for melody, you're looking for specific notes, and you cannot convert directly these geometrical notes into music. I can show you an example. Here you have like notes in the second line. So okay, now it's the L2, but if you have different clefs before it will be different notes. So it does not have a direct conversion. Also, if you want to introduce a specific musical melody, you will have a lot of possible representations of different geometries. So you have not a direct conversion. So what we propose here is to make the queries like through a piano interface we implemented. You look for the melody, but internally you're looking for this musical query in each clef. So the query, the geometrical translation query will be, if you want to look for do re mi, it will be for C1. This is the syntax for the demonstrator. You will look for this geometry, or for clef 2, you will look for this geometry, or for clef 3, C3, this geometry, and you look for all the, I mean, this will be the whole, this on the right side, the whole query for the system if you're looking for this music. So that's a kind of automatic, because the user just needs to put the music, and then the computer internally or the web page will translate this music to this enormous query. And yeah, we also implemented this like two kind of search. Will be the key search and no key search, where the key means you mind the key in which the melody was written. I mean, if it's do re mi, it will look for do re mi, even like doesn't matter the clef. But if it's no key, it will be do re mi, but it will be also sol la si, and it's like you can look for transposed melodies, which converts the query into a much larger or geometrical query. So this, I mean, I'm going to put some average precision results here. They are pretty good. Like it's 0 would be the worst and 1 would be the best. And it's I don't know if I will explain this before after, if someone has doesn't know what's the average precision result. But I mean, it is good information retrieval measure. So in the end, we have these intuitive input realistic musical queries that benefits from probabilistic indexing in the recognition step, but also can benefit from the musical input from the user. And as future work, we of course need to refine the web page, because I'm going to show it you now. But I don't know if we have time to show the web page, but I'm sure there are a lot of bugs in it. And also extend this methodology to other notational systems, not just ancient manuscripts, also for other types like modern or other types of music, and not just minding the music per se, but also the clefs, or not the clefs, but the rhythm or more voices or whatever. I don't know how much time I've been talking, but
1 minute.
is there reason for
You have 1 minute.
Okay, so yeah, I just show you. You have this, but I mean, you can look for a melody. You can like in the convert button, you will convert it to a geometry query, and then you look for it, and it will retrieve the information here in what page it has found do re mi. And you can see here, for example, like this is maybe a mistake because it's like F. Yeah, it would be this one, F3, and also S1, S2. Yeah, so we found do re mi will be this. Here you can click and look for the single note spotting. And I wish I had much more time to show you more features of this, but I mean that I think this is enough for this presentation. So thank you for listening. It was really quick. I'm sorry.
Well, it's okay. It's okay. Thank you. Thank you very much, Aitana. Okay, it's time for questions. Any question from, well, I was going to say from the audience, just the online audience. Okay. Well, I have some. If
Mhm.
nobody else is asking, I would like to make you a few questions. Um, I know this is more like demo. I mean, you are presenting the more the ideas than the performance. But since you show some results, I wanted to ask these results. I'm not sure where they come from. I mean, for example,
Yeah.
the query set. I think it's something I've always wondered if you're going to evaluate a retrieval system. How do you select the query set? And since you are providing metrics, but these metrics of course depends on the query set. So
Okay.
can you elaborate
Yeah,
that?
of course. Yeah, it was really quick, so I didn't have like, I prefer to focus on because we are working on really evaluating this performance of music queries. But yeah, we are already have done that, but we haven't published it yet, so I didn't want to focus on that. But yeah, I can tell you, like the query set, we chose 185 Gregorian melodies. We it's from a book of Gregorian chant, like we extract them from there. So it's 185 melodies that we converted to geometrical queries. So I don't know, maybe like they were from 3 to 7 note melodies, and they have different sizes, different lengths, and that's we converting. I can show you. Yeah, we convert them to geometrical queries like this one. So each melody of this Gregorian chant will be one of these geometrical queries, and also we performed the key search and also the no key search. With also it's more average precision because you also have more information to retrieve, so you cannot compare this to this directly because it's one is for one like just minding the key and then the other it isn't. I wish just little like short results, but it's not. I didn't want to focus on that, just to say like it's working, but you cannot say it's working better than anything because it's not comparable to anything. But yeah, it's from already like real Gregorian chant melodies. So
Okay. Well, if nobody else is wants to ask, I'll make another question. Um, how do you plan to, or maybe you're not planning to, but how do you plan to extend this to more types of music? Because my question is because here you just need the position of the in this scores. It seems that you are ignoring the rhythm in the notes, but if you bring this into modern notation where each note also has rhythm or dynamics, maybe you have different voices simultaneously. So I'm wondering how the query, I mean the transformation into the queries is going to explode, because now for a simple uh, three symbol query you show a very long string
yeah.
for the whole query. And how is it possible to scale this, to expand this to more rich queries?
Okay, that's the main problem, that it's not super efficient, like scalably, like if you put more information to it. Maybe we haven't tried to implement this on other types of manuscripts, but I feel like for example the rhythm, like maybe this is like also the conclusion I extract from this is that maybe you don't need your information to be in musical way, like it's just geometry, and you can benefit yet from music and also use musical translation in this, but also it's not scalable. But I feel like we should not just focus on what we have after the model with this geometrical symbol, but also training the system with music and also like already rhythm or whatever. I feel rhythm maybe it's not that important in the sense that if your optical model learns the figures and you have like well separated figures and with the bars, maybe the computer can later, I mean, you don't need automatic learning for this, like machine learning to automatically learn everything, but you can also benefit from regular algorithms to computate searches or whatever. But also it's like a really good question because we haven't worked on that yet. We are doing other things, but I feel like we should try this and see how can we manage to do with other data types and also with the types of encoding, musical encoding.